Good morning, one and all. So now we are going to discuss about gate multiple choice questions on Fourier series. Question number 1. So Fourier series applied to only periodic signals, only aperiodic signals, both A and B, only for the random signals. The answer could be A, only periodic signals. And second question, for existence of Fourier series, Dirichlet conditions are sufficient, necessary, necessary or sufficient, none of these. The answer could be a necessary and sufficient condition. For existence of Fourier series, Dirichlet conditions are sufficient and necessary. The net area of sinusoids over a complete period is finite, infinite, 0 or none of the above. The answer could be 0 because both positive and negative cycles will be there, having the same magnitude, but there is 180 degree phase shift. Automatically, the overall area is going to be 0. So the answer could be C. So coming to the fourth question, the even symmetry is called rotation symmetry, mirror symmetry, full symmetry, or half symmetry. The answer could be a mirror symmetry because the x of t equal to x of minus t is the even signal. So the mirror image is always be equal to the original signal. So exponential Fourier series representation of a signal over the interval t0 to t0 plus capital T is given by sigma n equal to minus infinity Cn e power minus Jn omega naught t, sigma n equal to minus infinity Cn e power Jn omega naught t, sigma n equal to 0 to infinity Cn e power minus Jn omega naught t, sigma n equal to 0 to infinity Cn e power Jn omega naught. So in this, the option could be B. According to the definition of the Fourier series, I can say the answer could be the B. Coming to the question number 6, the exponential Fourier series coefficient is given by. So it is 1 over t integral t0 to t0 plus capital T x of t power Jn omega naught t is one option. 1 over t integral t0 to t0 plus capital T x of t power minus Jn omega naught dt is second option. Integral t0 to t0 plus capital T x of t power minus Jn omega naught t is third option. Similarly, integral t0 to t0 plus capital T x of t power minus Jn omega naught dt is the fourth option. So the answer could be B, because from the definition you can get it. So in the trigonometric Fourier series representation of a signal, small a0 or capital A0 is the RMS value, mean square value, peak value, or average value. So if I just go through it, according to the definition, it is the average value. And because A0 equal to 1 over t integral t0 to t0 plus capital T x of t dt. Question number 8. The trigonometric Fourier series representation of an even function consists of a cosine terms only, sine terms only, both A and B, none of the above. So because signal is an even function, the function could have only cosine terms. So answer could be A. Similarly, for the trigonometric Fourier representation of odd function consists of only cosine terms, only sine terms, both A and B, and none of the above. Answer could be sine terms because only Bn components will be available here. The coefficient Bn is 0 for the function. For which function Bn is 0? For when signal is even signal, Bn could be 0. Similarly, the coefficient An is 0 for the dash functions. So if the signal is odd, then An will be 0. Automatically answer could be B. So the trigonometric Fourier series representation of a function with half-wave symmetry consists of cosine terms only, sine terms only, odd harmonics only, even harmonics only. So whenever it is a half-wave symmetry, only odd harmonics will be available. Because if x of t equal to x of minus t, then the signal is odd and only odd components will be available. So periodic function x of t is said to have a half-wave symmetry if x of t equal to half of x of minus t, x of t plus capital T by 2, x of t plus or minus t by 2 minus x of t plus or minus t by 2. So the answer could be D. According to the definition, I can have half-wave symmetry is x of t equal to minus x of t plus or minus t by 2. And question number 14, the most widely used Fourier series is trigonometric Fourier series, cosine Fourier series, exponential Fourier series, none of these. So most widely in Fourier series is a cosine Fourier series rather than trigonometric or exponential. Coming to the question number 15, the trigonometric Fourier series has dash spectrum 1, 2, both A and B, none of this. This is only one-sided spectrum, that is A. An exponential Fourier series has 1, 2, both A and B, none of this. So here it is a two-sided spectrum. Exponential Fourier series has two-sided line spectrum because Cn is a complex number. An exponential Fourier series has, in terms of Cn, if you want to represent, Cn equal to 1 by 2 an minus jbn, Cn equal to 1 by 2 an plus jbn, Cn equal to an minus jbn, Cn equal to an plus jbn. The answer could be B because it is sum of an plus jbn by 2 is the Cn. Similarly, from the derivation, we get it. Similarly, the exponential Fourier series coefficient C minus n is in terms of trigonometric Fourier series. Almost similar definitions here. Cn equal to 1 over 2 an plus jbn, P equal to C minus n equal to 1 by 2 an minus jbn, C minus n equal to an minus jbn, Cn equal to an plus jbn. So the answer could be simply B again. So question number 19. The trigonometric Fourier series coefficient an in terms of exponential Fourier series is an equal to Cn plus C minus n, an equal to Cn minus C minus n, Bn equal to Cn minus C minus n, Bn equal to Cn plus C minus n. The answer could be A because sum of these two will be an. Similarly, for Bn, similar definition you will be getting. So the trigonometric Fourier series coefficient Bn in terms of exponential Fourier series coefficient can be Bn equal to j into Cn plus C minus n, Bn equal to j into Cn minus C minus n, an equal to Cn minus jcn, Bn equal to an plus jcn. The answer could be B, j into Cn minus C minus n. So this is also from the derivation you can get it. Similarly, question number 21, the frequency spectrum of a period signal is a continuous, discrete, both A and B, and none of this. So whenever you take the frequency spectrum of Fourier series, is always be discrete in nature. So the frequency spectrum of period signal is always discrete. So question number 22, the frequency spectrum of a period signal is continuous, discrete, both A and B, none of these. Frequency spectrum of a period signal is always be continuous in nature because Fourier transform of any signal generally be aperiodic in nature. Fourier transform applied only for aperiodic signals. Automatically, the frequency spectrum of aperiodic signal is always continuous. The amplitude spectrum of exponential Fourier series is about vertical axis. About vertical axis is symmetrical, anti-symmetrical, both A and B, none of these. So generally, amplitude spectrum is symmetrical in nature because we always try to have the spectrum both in positive direction and negative direction of the vertical axis. The phase spectrum of exponential Fourier series is about vertical axis is symmetrical, anti-symmetrical, both A and B, and none. So the answer could be anti-symmetric. phase spectrum of exponential series is about vertical axis symmetrically. So question number 25. The time domain representation of a signal graphically called a waveform, a spectrum, a magnitude, and phase. The answer could be a waveform because time domain signal always be represented in the form of wave. So the time domain representation of a signal graphically called a waveform. Frequency domain representation of signal graphically called waveform, spectrum, magnitude, and phase. So generally we consider this as a frequency spectrum rather than a waveform. So I can have the answer could be B. The frequency domain representation of a signal graphically called the spectrum or frequency spectrum. Question number 27. The cosine Fourier series is called a polar Fourier series, harmonic, both A and B. Fourth one is phase. So generally cosine Fourier series either harmonic or periodic, polar. So answer could be C, both A and B. So cosine Fourier series is both in polar form and harmonic in nature. So last question, the Fourier series representations are based on using constant coefficients, only cosine functions, only sine functions, and orthogonal functions. Fourier series is applied for orthogonal functions only. So answer could be D. So this is the overall one.